This is the last video in the test 4 review, and it covers material on polar equations and graphs. In this problem, we're given the point 4 pi over 4, and we're asked to plot it in polar coordinates and give the rectangular coordinates of the point. So remember, when we're graphing in polar, first we're going to want to graph the angle on the axis. So if we were to graph pi over 4 on here, granted this is just a rough sketch, it's hard to do graph polar coordinates sort of in this format, but pi over 4 would be pretty much, that would be the angle pi over 4. And then once we have our angle, we're going to move 4 units out from the pole. So we're going to just say that this is approximately 4 units out from the pole. This isn't to scale, but you sort of get the point of what you have to do is you are going to find your angle on the graph and then move however many units away from the pole. So that's just sort of a rough graph of our 0.4 pi over 4 on the polar graph. And then we want to find this point in rectangular coordinates. So when we're converting between polar and rectangular, it's important to remember that x equals r cosine of theta and y equals r sine of theta, where 4 is our r and pi over 4 is our theta. So x would be 4 cosine of pi over 4 and y would be 4 sine of pi over 4. So we're going to have 4 root 2 over 2, which would just be 2 root 2. And similarly, we'll have 4 root 2 over 2, which would just be 2 root 2. So our rectangular point would be 2 root 2, 2 root 2. So in this question, we're given the rectangular coordinate -4, 4, and we're asked to give 2 pairs of polar coordinates for the point, and we're keeping on the interval, we're staying between 0 degrees and 360 degrees. So when we're converting from rectangular to polar, it's important to remember that r is going to be equal to the square root of x squared plus y squared. And we can find theta by looking at tangent of theta equals y over x. So in this case, r is going to be the square root of -4 squared plus 4 squared, which would be equal to the square root of 32, and we can rewrite that as 4 root 2, and then we would have tangent of theta equals 4 over -4, which is -1. So for this problem, it's important to know that our point -4, 4 is going to be in quadrant 2. So that's going to help us determine what our theta needs to be. So we need to find the value in quadrant 2 where tangent of theta is equal to 1. Okay, so in quadrant 2, tangent of theta is equal to -1 at 135 degrees. So that's going to give us the coordinate, the polar coordinate 4 root 2, comma, 135 degrees. So to find a second point, we can use -r as our coordinate, so that's going to be -4 root 2. And so that's going to move us sort of the opposite direction with our pole. So we need to find the angle that would make a ray away from the origin in the opposite direction of 135 degrees. So we can do that by adding 180 degrees to 135. So 135 degrees plus 180 degrees is going to be equal to 315 degrees. So our second point would be negative 4 root 2, 315 degrees. So let's just get a visual of that so we can see how those points are describing the same spot. So with our first point, 135, 4 root 2, 135, our ray of 135 degrees would happen over here in quadrant 2, and we would move 4 root 2 units away from the origin. So we would have a point approximately there. So with our second point, negative 4 root 2, 315, 315 would create this ray out in this direction, and we're moving negative 4 root 2 units away from the origin or from where this ray starts. So that's going to move us back up into quadrant 2. So if we're working, we can do that in green. We're going to move negative 4 root 2 units this direction, and we can see that this is just going to create the same point. In this problem, we're given the formula x squared plus y squared equals 49, and we're asked to convert it into a polar equation. So remember that x equals r cosine of theta when we're converting between polar and rectangular, and y equals r sine of theta. So we can substitute those in for x and y, and we would have r cosine theta squared plus r sine of theta squared equals 49. So we can factor, we can simplify this to r squared cosine theta, or cosine squared theta, plus r squared sine squared theta equals 49. Then we factor out an r squared, so we have r squared cosine squared theta plus sine squared theta equals 49. Now remember, this is just an identity, it's equal to 1. So we now will have r squared equals 49, and we can take the square root, and r equals 7 or negative 7. So that's going to be our equivalent polar equation. In this question, we're given the equation 2x plus y equals 3, and we're asked to convert this rectangular equation into a polar equation. So let's just remember these relationships that we have real quick. We know that x equals r cosine of theta, and x squared plus y squared equals r. We also know that y equals r sine theta, and tangent of theta equals y over x. So these are our conversions we use when we're going between polar and rectangular. And just to give a visual of why that is, if we had this point here, we could consider in polar this to be r and this to be theta. In rectangular, we'd have y and x where we go to this point x, y. Or in polar, it would be r theta. So as you can see, we can relate all of these different things to each other using our trig functions and things that we know about triangles. But we're going to go ahead and take what we know and convert 2x plus y equals 3 into polar. So we can substitute in, we have 2 r cosine theta plus r sine theta equals 3. So we can factor out an r. We have r times 2 cosine theta plus sine theta equals 3. And so we're solving for r. We get r equals 3 divided by 2 cosine theta plus sine theta as our final answer. So in this question, we're sort of working in the opposite direction of what we've been doing previously. We're given that r equals 6 cosine theta, and we're asked to convert it into rectangular. So as we've been doing in our other problems, let's just remember some of our conversion facts. We know that x equals r cosine theta y equals r sine theta, and r squared equals x squared plus y squared. So, using this then, we know that in our case, r squared equals 6r cosine theta, which I just got from multiplying both sides by r. And we know that r squared is x squared plus y squared, and r cosine theta is equal to x. So what we have now is x squared plus y squared equals 6x. Then we can say that x squared plus y squared minus 6x equals 0. So this is an equation of a circle, and we're going to need to write it in standard form by completing the square, and we can do that by adding 9 to both sides. So if we add 9 to both sides, we would have x squared minus 6x plus 9 plus y squared equals 9. And we can then factor this part, and we would have x minus 3 squared plus y squared equals 3 squared. And that would be our final answer. So you may want to just brush up on your completing the squares skills, just so that when you're working on a problem like this, you would know how to get to your final answer, because you're going to need to put it in the correct form. Okay, so we can just go over a summary of what we've covered, and there's also a little bit of material that wasn't covered that's important to know. So you're going to want to know the names of your different types of polar graphs. So obviously any graph that looks like this is just a circle. Then we also have some that can look like a little bit like a figure 8. So they may look like this. Those have a special name as well. So we've got these type of graph. Okay, so additionally you may see graphs that look like this. And those have a name. So you may be asked questions on your test where you're asked to identify the type of graph it is. So it's important to just sort of look over this information. And obviously these are rough sketches, so you may be better off just doing some practice problems or looking in your notes, because this may not necessarily be the most helpful thing in the world. It's really hard to draw these on here. But anything that looks like this, basically like a flower, that's a rose curve. So that's going to be important to remember. So I've said this a bunch of times through this video, but it's just important to remember that when you're converting between rectangular and polar, you need to remember x is r cosine theta, y is r sine theta, r squared equals x squared plus y squared, and tangent of theta equals y over x. So those are the 4 things that you're going to need to know whenever you're converting back and forth between rectangular and polar. And as I said, it could be a good idea to brush up on your completing the squares skills or your factoring skills, because that may come in handy in writing out some of your equations in the right form. So you've got your conversions, you've got your different types of polar graphs, and then it's also important to remember that when you are graphing in polar, you're going to start by figuring out what your ray would be for your angle theta. So we would have this ray for angle theta. And then depending on what r is equal to, you're going to move r units away from the origin of your ray. So if r was a positive, if r was 3, then you would move 1, 2, you would move 3 units away from the origin. But if r was equal to negative 3, you'd be moving 3 units in the opposite direction, so you would have your point over here. So just keep that in mind. You need to remember which direction you're moving from the origin when you're graphing in polar, because that can get a little tricky. So this is the final video in the Test 4 review, and as always, there are more practice problems that you can go and do if you get on my Math Lab and look at the customized non-credit review for Test 4.